on this and some questions for practice. I just want to remind everybody, if you are struggling with a concept, if you're having a hard time with a concept, or you're not finding the right answers to the questions, I'm here Mondays, Tuesdays, and Thursdays. I can be here until 4 o'clock. So come in at lunch or after school if you need help. Make sure you guys are keeping up with the work and doing the homework. You should be able to answer questions on these things and like fully understand them as we go, not just when we get to the end of a unit and get a test. So make sure that you're kind of assessing yourself as we go. Am I able to do this? Would I be able to go through and do a quiz on this tomorrow and get it? Yeah. It's so yeah, I mean, if you didn't do well and you didn't feel comfortable on this quiz, just make sure like you're doing the homework and you're checking in with me if you have questions, working with your peers who are getting this stuff, and going over it, making sure that you're doing it right. Okay, so today we're going to talk about percent composition. So this is kind of building off of the idea of finding how many atoms there are in a molecule. All right, so percent composition. So percent composition is the percentage by mass of each element. It's not on the thing. I'm just talking to myself out there. Oh my gosh, thank you. Okay, so the first sentence here is the percent composition is the percentage by mass. By mass is the first blank. Of each element is the second blank. In a compound is the third blank, and the projector is just turning on as we go. But basically what we're looking at is how much of something by mass is in an element. So far what we've been doing is we've been seeing like, okay, I've got NaCl. I have got how many atoms of chlorine in a molecule? 1. I've got how many sodiums in this molecule? 1. Or we've been looking at CO2. Okay, I've got 2 oxygens and I've got 1 carbon. But what we're going to start looking at now is, okay, how much percentage of the mass of that molecule is taken up by each of these elements? So if we look on our periodic tables, is oxygen or carbon heavier? What do you guys think? Yeah, oxygen is heavier. So the percentage of the mass of this molecule is not just going to be 2 to 1. It's going to be more complicated because we're actually looking at a heavier molecule, 2 of a heavier molecule for 1 of a lighter molecule. So we're finding the mass of these things. All right, so percent composition of water we're going to start off with. So we're going to assume that we've got 1 mole of water. So we're just going to use the molar masses for our calculation. So again, water is H2O. So what we're doing is finding the molar mass. Yeah. So we're finding the molar mass of water. So we've got 2 times whatever the hydrogen's mass is plus 1 times whatever the oxygen's molar mass is. And what we end up with is 2 times 1 plus 1 times 16. Do you have to write this all out? No. Am I going to? Yes, just to make sure we're with me every step of the way. Okay, so then we've got 18.0. And this is going to be in grams per mole. So our molar masses are grams per mole. So that is my molar mass of water. But what I'm looking for is what percentage of that mass comes from oxygen, what percentage of that mass comes from hydrogen. So to find that out, what I'm going to do is go Okay, what percent is hydrogen? I've got 2 grams of hydrogen in this, right? 2 grams of hydrogen for every 18 grams of H2O. So if I divide 2 by 18 and I multiply it by 100 to get percent, I should get 11.1%. So 11.1% of the mass of water comes from its hydrogen molecules. It would be easy to just subtract that from 100 and get the mass of oxygen, but we're just going to go through the process as well for oxygen. So percentage of oxygen, I have got 1 oxygen, so I'm going to do 16.0 grams of oxygen per every 18.0 grams of water. And that's going to give me 88.9%. So 88.9% of the mass of water is the oxygen in it, and 11.1% of it is the mass of hydrogen. So even though in the actual water molecule, I've got 2 hydrogens for every 1 oxygen, the majority of its mass is actually coming from that 1 oxygen. Does that make sense? Any questions about that? Okay, so let's do copper sulfate pentahydrate. All right, I'm going to give you all a moment. I want you to find the molar mass of this. So work with whoever's at your table. You're finding the molar mass of copper sulfate pentahydrate. All right, does anybody have a molar mass for me? 249.6 grams per mole. Does anybody else have something different, or is that what we all got? 201.6? Okay. All right, so what we've got, we have 1 copper. Copper's got a molar mass of 63.5. We've got 1 sulfur, which has a mass of 32.1 grams per mole. We've got how many oxygens? Yep, 4. So 4 times 16. Okay, how many hydrogens do I have? 10 hydrogens. They've got a mass of 1.0. How many oxygens do I have? 5 oxygens. So when we add those all up, you guys should be getting 249.6. So just make sure you're really paying attention to this 5 waters. I think that throws a lot of people off with the hydrates. Okay, so 249.6 grams per mole. So the total, oh, whoops. Oh, right, sorry. We're looking for the percentage of water. Okay, so what we have to do, if we're looking for the percentage of water, we need to find what the total mass of water in one of these molecules is. So we're looking for the molar mass of H2O. Okay, so we did that above, and it's 18, right? All right, so then in order to figure out percentage of water, oh wait, no, sorry, I'm wrong. Yeah, molar mass of water is 18, but then there's 5 per molecule. So mass of H2O per molecule of the CuSO4 5H2O. So the mass of water per molecule of that is actually going to be 90 grams. Or per mole. Yeah, total mass of water in that molecule is 90 grams because there's 5 of it. Okay. So in order to find the percentage of water in that, what we're going to do is go 90 grams divided by 249.6 grams. And we can just assume that there's 1 mole. So this is like grams per mole, but we're just assuming there's 1 mole. So I'm just going to throw it in grams. Yeah, Amber? That's a really great question. So would the 5 make it just 1 sig fig because there's 5 H2O? So because 5 is not a measured number, it's not something that's going to count towards our sig figs. So 5 is a definite number. You have exactly 5 H2Os. So you could think about that as like 5.0 for infinity, right? It's 5 as a definite number. So if it's a measured number, like grams, then it's going to count as part of your sig fig. If it's a definite number, like how many of a molecule you have, or like 1 dozen, 12, that would be not something that would count towards your sig figs because it's a definite exact number. Does that make sense? Okay, cool. All right, so percentage of water is 90 divided by 249.6 times 100. So I end up with 36.0% water. Okay. And do I have the right number of sig figs? 3, 3, 4. Yep, good. Okay, any questions about that? Yeah. Yes, yeah, you do. Yes, so you do use significant figures and percentages. Okay, cool. So what I'm going to get you all to do now is there's page 91 questions here. And then there's also a worksheet up here. So I want you all to work on those 2 things. I'll give you about 20 minutes to do that, and then we're just going to start on 5.5. So spend some time doing that. Ask questions if you have them.